This is another example of a geometric proof involving triangles. These are not overlapping triangles, but they are a situation where you're certainly going to have to use CPCTC to solve them. And when you look at this, you're given all this information about D as the midpoint of those. And really, there's just no other good way to start this than to just deal with that given situation. That given tells you that those are congruent, and then you've got BD congruent to DG, since D is the midpoint of all those. So after the given, which is just right here, you're going to write that AD is congruent to DF. You can write that CD is congruent to DE. And you're going to write that BD is congruent to DG. And on this, that's all because of your definition of midpoint. Right? If you've got a midpoint, then that means it creates two congruent segments. Now, all of that is good because we also know that angle ADC is congruent to angle EDF. And that's because of vertical angles. And so with that, you actually, if you started out like the way I did here, you actually have two different triangles that you can prove congruent. You've got the obvious small ones, right? Triangle ACD congruent to triangle. So ACD congruent to, and it's going to be starting with F, FED. Those two are kind of easy ones to see, and that's by side angle side. But if you get rid of that stuff and realize that, wait a second, I also have AD congruent to DF, which I used for that one, but I have BD congruent to DG, and still the vertical angles. So the big triangles, ABD, is also congruent to the big triangle FGD. And noticing that you can prove both of those triangles congruent off of this information is very valuable. Because your ultimate goal is to show this one congruent to this one. And so now you've got a bunch of interesting things. For instance, we can do a bunch from CPCTC. And really, we want to do things that are involved in this triangle. So we could say AB congruent to GF, right, by CPCTC. That's from the big triangles. You can say that angle B is congruent to angle G. You can say that AC is congruent to EG, no, not EG, EF. But if you look closely, those information, that's here and here, that's here, and then it's these two angles. And so that actually results in side-side angles. So you can't use that to prove these congruent. And so we're still not there yet, even though we had all this information. So there's a couple ways you could do this. There are actually about 4 different ways. The way I'm going to show is I'm going to also show that ACD is congruent to DEF. And that is because of, that's also because of CPCTC. So we can actually write that in this one right here. And then I'm going to use a very powerful theorem. So this is all CPCTC. Congruent, or corresponding parts of congruent triangles are congruent. And then I'm going to go ahead and show that angles, angle ACB and angle ACD are supplementary, and angle DEF and angle FEG are supplementary. And that's important because we're talking about these two pairs of angles there. And that's important because you know that ACD is congruent to DEF. I wrote that down. So now there's a great theorem called congruent supplements that says if two angles are supplementary to the same angle, which doesn't apply here, but if we say two angles are supplementary to congruent angles, that does apply, then the two angles are congruent. So now we can claim ACB congruent to FEG. And that now gives you enough to prove that the two triangles are congruent. Triangle ABC congruent to triangle FGE. And that is by, so 6 was linear pairs are supplementary. 7 is the congruent supplements theorem. And then 8, because I have the two angles and then I got the two sides, it doesn't matter which one I use. I'm going to have angle, angle, side. Some other things you could have done. You could have proven that AB is parallel to FG. You could have proven that AC is parallel to EF. That would have been another way to prove that ACB is congruent. If you prove that AB is congruent to EF, if you extend these lines, that would mean this angle is congruent to that angle, and that angle is congruent to that angle. And so if you put a point in here, you could go through and use transitive property to show that these two angles, this angle and this angle, are congruent. You could have also done segment addition and shown that this side is congruent to that side and use side, side, side. A lot of ways to do this problem. This is just one example of a way to get to a final solution.